Okay, let's kick things off. Today, we're doing a deep dive into basically a handbook for tech interviews. We're hitting C# fundamentals, Web API, SQL Server, the works. Our mission, really, is to pull out those key insights, maybe some surprising facts to get you properly informed fast.
Absolutely. And what's interesting is how these topics, they seem separate, but they often, connect underneath. We'll look at core principles, how they actually play out in the real world, trying to spot those little details that make a big difference in understanding, get those aha moments going.
Okay, first up, a classic C# area that trips people up, system.string. You think string concatenation simple, right? But that immutability, it has a hidden cost, a big one.
It really does. Every time you use plus inside a loop, you're not just adding to the string. C# is making a whole new string object every single time.
Wow, so that's memory allocation over and over again.
Exactly. And then the garbage selector has to clean it all up. It can really bog things down. That's precisely why system.stringbuilder exists. It's mutable.
Meaning it changes the existing string data in place.
Correct. It uses an internal buffer. So for lots of changes, especially in loops, it's way, way more efficient. I remember debugging a system once, performance was terrible, and yep, string plus in a tight loop was the culprit.
Makes sense. Okay, sticking with C#, let's talk polymorphism. Most developers get the basic idea, but there's a subtle difference between method overriding and method hiding. It's a common interview question, too.
It is. Overriding, using virtual and override, that's your standard runtime polymorphism. The actual type of the object at runtime decides which method gets called. Predictable.
But method hiding is different, uses the new keyword.
Right. And here's the crucial part, especially if you're designing APIs. Using new essentially breaks that expected polymorphic behavior. The compiler decides based on the variable type, not the object's actual type at runtime.
Ah, so you might call a base class method when you expected the derived one.
Exactly. Can lead to some really sneaky bugs. If you want proper extensible polymorphic behavior, you need virtual and override. Stick with those.
Good advice. Okay, shifting gears a bit, let's talk Web API security.
Yeah.
Specifically, authentication with JWTs and refresh tokens. It's usually a dual token approach we see now, right?
Pretty much standard practice, yeah. You have short-lived JWTs, they access tokens. They're great because they make the API stateless. They carry claims who you are, what you can do right in the token itself.
But short-lived is key.
Absolutely vital. Limits the window if a token gets compromised. Then you have the longer-lived refresh token. Its job is just to get new access tokens.
And that's often stored more securely, like in an HTTP-only cookie.
Ideally, yes. HTTP only means client-side JavaScript can't touch it. Big defense against XSS attacks trying to steal tokens. The client uses this refresh token, usually behind the scenes, to get a new JWT when the old one expires, without the user having to log in again.
Smooth experience.
Yeah, but security is paramount. Refresh token rotation is a key best practice here. When you use a refresh token to get a new access token, you also get a new refresh token, and the old one is immediately invalidated.
Okay, so even if an old refresh token was stolen, it becomes useless quickly.
That's the goal. Makes it much harder for attackers.
Right. Okay, from securing APIs to optimizing databases.
Yeah.
SQL Server time. Let's tackle a common performance headache. Parameter sniffing in stored procedures.
Ah, yes, parameter sniffing. SQL Server tries to be clever. It creates an execution plan optimized for the first set of parameter values it sees.
But that plan might be terrible for different values later on.
Exactly. It gets stuck with that initial plan, can lead to wildly inconsistent performance. A common fix is to kind of de-sniff the parameters.
Let you do that.
Inside the procedure, you declare local variables and copy the input parameters into them. Like declare at localide int ixlees atputed, then use that localide in your query. It often forces the optimizer to create a more general, less specific plan.
Interesting workaround. And while we're on SQL performance, temp tables versus table variables.
Good question. For anything beyond, say, very small data sets, temporary tables, #temp generally win. The key difference is that temp tables can have statistics and indexes created on them.
Which the query optimizer can use to make much better decisions.
Precisely. Table variables at table don't have statistics in the same way, so the optimizer often makes very conservative guesses about row counts, leading to less efficient plans for larger amounts of data.
Got it. One last SQL point. User-defined functions, or UDFs. There's a strict rule about what they can't do.
A very strict rule. You absolutely cannot use DML commands inside a UDF. So no insert, update, delete, or merge.
Why is that?
It boils down to database design principles. Functions are meant to be deterministic, same input, same output, and crucially side effect free. They shouldn't change database state.
They just compute and return a value.
Exactly. If you need to modify data, that's what stored procedures are for. They are designed for side effects and transactions. It keeps things clean and predictable.
Wow, okay, so we've gone from C# memory quirks and object design nuances all the way to API security patterns with tokens and some deep SQL optimization details. That was quite the tour. Hopefully everyone listening feels a step closer to really owning this stuff, not just knowing it.
Definitely. And, understanding these things, it isn't just about interview prep, is it? It's fundamentally about writing better code day to day. More robust, faster, easier to maintain code. Which leads to a final thought, maybe for you to ponder. When you're coding next, how often will you consciously think about these underlying mechanics? About the real impact of choosing, say, string concatenation over string builder or method hiding over overriding? Where are the opportunities to apply this deeper understanding?